Hello. In this video, I'm going to be going over AICE Physics, syllabus code 9702, paper 11 from May-June 2018. This is question number 21 from that paper. I have previously gone over question number 20 as a worked example. This question very clearly aligns with the learning outcome to be able to state the wavelengths of the principal radiations of the electromagnetic spectrum. While the question asks about frequency, the learning objective is to know what the wavelengths are, and if we're mindful that the speed of light, c, is a constant equal to wavelength times frequency, then by knowing the wavelengths and by knowing the speed of light, we should be able to deduce the frequencies that way. So that's one way if you don't have like all of the frequencies memorized, but you do happen to recall the wavelengths, that you could calculate the frequencies that way. One thing to take a look at here is the question in its entirety reads, which region of the electromagnetic spectrum includes waves with a frequency of 10 to the 7 megahertz? One thing to keep in mind is that mega is a metric prefix that stands for million, right? So it's 10 to the 6. And so what we're really saying is, what's an electromagnetic wave that has a frequency of 10 to the 7 times 10 to the 6, or a frequency of 10 to the 13 hertz? So that's really what we're looking at there. Something with a frequency of 10 to the 13 hertz. So let's calculate the wavelength. If the speed of light is actually one of the pieces of information given on the list of data as you sit for papers 1 and 2. Speed of light is approximately 300 million meters per second. It's known a little bit more precisely than that. The actual speed of light is 299,792,458 meters per second, but we round it up to 300 million because it's pretty close. So 3 by 10 to the 8 meters per second. And then if we divide each side by the frequency, 10 to the 13, we can solve for the wavelength there. It's important to keep in mind that this is really only helpful if we've got those wavelengths committed to memory. So we got 3 by 10 to the 8th divided by 10 to the 13. And so we're looking for something with a wavelength of 3 by 10 to the negative 1, 2, 3, 4, 5. 3 by 10 to the negative 5 meters. All right. One of the things that I think is helpful to sort of think about the electromagnetic spectrum is to sort of anchor your memorization onto something that's more familiar to us, which is the visible part of the spectrum. And so I'm just going to go ahead and lay out the entire spectrum from longest wavelengths to shortest. We've got radio waves, microwaves, infrared, red to violet constitutes the visible part of the spectrum, the part that our eyes can detect. And then we've got ultraviolet, which has a higher frequency than violet. So while its wavelength is shorter, it occurs more frequently, right? So its frequency is higher as we go from left to right, the way I've written it. Then we have X-rays, and finally gamma, which are the shortest wavelength, the highest frequency, and energy is also proportional to frequency. And so the highest energy types of light are found here where the highest frequencies are. So if you recall that red light is 7 by 10 to the negative 7. All of the units here are going to be in meters. And remember, we're decreasing the wavelength. So violet light is about 400 nanometers. So 400 nano is about 4 by 10 to the negative 7 meters. So if you kind of recall that we can see between 400 nanometers, or 4 by 10 to the negative 7 meters, up to 700 nanometers, 7 by 10 to the negative 7 meters, and then we kind of go, everything else kind of goes up by orders of magnitude from there. So radio waves go from anything that's like greater than 1,000,000 down to 10 to the negative 1. Microwaves have a wavelength from 10 to the negative 1 to 10 to the negative 3. And so infrared goes from 10 to the negative 3 all the way up to red there, right? And so infrared is a little bit longer wavelength than red. So because we know that we're looking for a wavelength by 3 by 10 to the negative 5, that's somewhere in the infrared, right? Infrared being 10 to the negative 3 up to red, which is 7 by 10 to the negative 7. Ultraviolet extends from violet light all the way as short as 10 to the negative 8. X-rays go from 10 to the negative 8 down to 10 to the negative 13. And there is an overlap between X-rays and gamma rays. Gamma rays go from 10 to the negative 10 to 10 to the negative 16. Those are the wavelengths there. Like I said, if you ever needed to calculate the frequencies, you could certainly do that. As just a rough calculation, you could kind of think that you know, everything is always going to kind of add up to 8. And so if you think about the wavelengths here, lambda, and the frequencies down here, then the exponents are always going to add up to the speed of light, 8. So that's sort of, you know, perhaps another convenient way to think about that. So this would go like 10 to the 2 up to 10 to the 9. 10 to the 9 to 10 to the 11. The units here for frequency would be hertz. We'd have 10 to the 11 to 10 to the 14. And visible light is all around 10 to the 14. You could actually get the exact values. Here you can kind of see that this rule of adding up to 8 doesn't quite work out because of the odd factor in front. So I think the frequencies for red light are like 4.2 by 10 to the 14, and then violet is like 7.5 by 10 to the 14, and then so ultraviolet would go from that, you know, almost 10 to the 15, but you know, from whatever it is, 7.5 by 10 to the 14, which is violet light, all the way up to 10 to the 16 there. So it's going to go from, you know, 7.5 by 10 to the 14, which is violet, up to 10 to the 16, and then X-rays would be 10 to the 16 to 10 to the 21, and gamma rays, like we said, have that overlap. Really, it's the source of this electromagnetic wave that sort of defines whether it's an X-ray or a gamma ray. We'll talk more about, you know, gamma rays when we study radioactivity and nuclear processes. Gamma rays are created in nuclear reactions like those that occur in the central part of the sun there. So 10 to the 18, 10 to the 24 would be the frequencies there. Now that's really tough to sort of commit to memory. There's a lot of information there. Maybe what I'll do is try to make like a vocabulary video or something. That'll probably be my next video that I upload after this one, like a vocab review.